Katy.
Hello, I'm Pauline.
I'm Louisa.
We've had a lot of questions from Chailey STEM Club and also Sithney Primary School. Hello.
Hey.
So we're going to try and answer some of them for you. We've had a question from Rosie. Where are we in the world? What's the climate like and what's beautiful about it?
So we're currently in the Atlantic Ocean off the coast of South America and the country Uruguay. And my favourite thing about it is the super blue colour of the ocean.
My favorite thing about it is to be alone in the ocean and to see the sunset and sunrises.
And the climate, well, because we're in the southern hemisphere, it's summer here at the moment, and it's quite warm and sunny. Today it's a bit muggy, and we've had really nice weather actually. You can see the sea behind us is actually quite flat. We've had a couple of days where it got a bit more wavy and stormy, and a few people got a bit seasick. And the water's really warm. It's about 23 degrees at the surface, but unfortunately we're not allowed to jump off and swim. But maybe that's a good thing because we've seen lots of sharks. So Owen has asked, what technology do you use to measure the seabed?
Okay, so we use a sonar with, so it basically uses sound that comes off the ship and it bounces from the seabed, and we can tell how deep it is with the time it takes to bounce, but we can't physically see it, so not like with a camera or anything.
So Jemima and StudyZone have been asking Katy, what are you doing all this research and have you found it?
So what are we doing? This is a bit hard to explain. So if you look at the oceans, they're always moving, and you can see they're always moving behind us. And we actually know quite well how the oceans are moving at the surface because we can put instruments that float at the surface, and we can also use satellites to take pictures of the surface and understand how it moves. But we really don't know very well how the waters move deep in the ocean and beneath the surface. So one of the aims of what we're doing here is to try and measure how the ocean is flowing deep beneath the surface, right from the seabed to the sea bottom, and we're using all sorts of methods to try and kind of map out how the oceans flow. And the reason that's important is because when water moves around the earth with the ocean, it carries things like heat and salt. You know, when you taste seawater, it always tastes quite salty, and it also carries things like nutrients, which are really important food for all the stuff that lives in the ocean. So it's important for us to understand how the oceans move and how they move all these important things around the earth, both for understanding the marine animals and plants that live in the ocean, but also understanding things like our weather and our climate. Yeah, what have we discovered? We've found loads of amazing pictures and images and information about how the ocean's moving. And I think new information to what we've known before, so I'm super excited about the data we've got so far. So we've got some questions from Toby, Rosie, Ruby and Jemima, and they're asking us lots of questions about what life is like on the ship.
So life on the ship, we have like a clear schedule, so it all revolves around the meal, basically breakfast, lunch and dinner. The food is amazing. So basically we wake up, we have breakfast, then we have a morning briefing for what we are going to do during the day. Then everyone goes to their task. Then we have lunch again. Then like the team of people working is changing for the afternoon. And the same dinner, people are changing. We have people working only at night. That was my case.
Yeah, and you have to keep working all through the night as well.
Yeah. So we are working 24 hours, 7 days, and
What kind of meals have we had? I mean, it's different every day, right?
We've got a kitchen making us food, so that's lovely. That's
all our meals made for us.
treat.
A lot of desserts, very good.
Oh yeah.
Puddings every day.
We have a lot of fish. Actually, that's quite. Yeah, fish and chips. That's good. What
Pizza's quite a common one.
Pizza.
Chili, curry. There's salads every day.
Ice cream.
Whenever you want it.
And biscuits and tea whenever you want it. So that's great.
And they were also asking about the fresh food. So when the ship leaves, they stock it up as much as they can with lots of fresh fruit and vegetables, but it does slowly run out, but it's been pretty good actually, hasn't it? I think.
But now we're at the end of the trip, we're getting, I think, more of the like tinned vegetables that are in there. But we used to have a lot of like fresh cucumber, fresh fruit as well in the mornings. I think we still have that in the mornings.
We still do.
That's good.
It is running out though, you can tell.
And then what our bedrooms are like.
Oh, what our bedrooms are like.
Like I have a bed, a desk, a shelf, and I'm sharing a bathroom with one of my workmates.
So what's good is that you have your own room. So I was expecting like I would share rooms with multiple people, but so that's quite nice to have my own space and then share a bathroom with one other person. So that's not that bad.
And some of the rooms have a little porthole window, so you can see the sea outside your window, which is nice.
So Thomas has asked, how do you use sound to measure what is below the surface?
That's a good question. So we're using sound to listen to some of the animals, and there's actually another video all about how we do that. But we're also using sound to measure what the different waters that make up the ocean look like and how they move. So if you imagine you've got a layer of water with hold that a minute. With another layer above it, then in a similar way to how we can we release sound to bounce off the seabed, we can release sounds that bounce off the boundary between those water masses. So it's a bit like taking a picture of all the different layers of water in the ocean.
So Nico has asked, why are you taking water samples?
So we are taking water samples because we want to know what the ocean is made of and we want to know what it carries. So basically what we mainly measure is temperature, so how hot or cold is the ocean. And we also measure how salty or not it is. And we also measure food, so that is important for the fish and the small living organism. And if we know all of this, we might be able to trace where the water masses have been before and where they are going to go after.
Okay, so a question from Jakub. What is the most fun thing about working on a ship?
My favourite thing is that I'm learning so many new stuff from everyone and a lot of different fields, so that's my favourite.
My favorite thing is to get to use all the different instruments and to get my data that I will be using for my work.
And my favourite thing is working where you're not stuck at your desk, but you're working with loads of people, you're having a lot of fun, making lots of new friends, and also having a relax in the evening with the sunset and playing some games. Games in the bar is good fun. So a question from StudyZone is, how many spare boats do you have if an emergency happens?
So as we can see here, we've got one lifeboat which fits 54 people. This one is on the port side, left, and then we've got another one on the starboard side, which is the right. And so those are the two main ones. We also have a lot of other lifeboats just in the other sides.
The smaller kind of life rafts. So we've got a question from StudyZone at Sithney School, and they're asking, who is the ship's captain?
So my name's John Leask. I'm the captain of the James Cook, and I've been captain on here on and off for 12 years.
And then Nico has asked, why is the ship called the James Cook?
So I don't know the original reason why the ship was called the James Cook, but I suspect it's something to do with the fact that Captain James Cook who set sail from the UK approximately 250 years ago to discover new lands, and he discovered the continent of Australia. Since then, James Cook, 2006 version of the James Cook, has also made discoveries all around the world as well, and I suspect it's something to do with that.
And then StudyZone have also asked, how do you navigate the vessel?
So we navigate the vessel in several ways. When we're out in the ocean, we can navigate the vessel using what we call a global positioning system, which is satellite systems that orbit the Earth, and we get our positions from them. We can also use the old-fashioned way, where we use sextants, where we take altitudes of the sun and the stars, and we can get our positions from that.
And then, how much does the ship weigh?
So James Cook weighs 4,000. Sorry, wrong. James Cook weighs 5,401 tons.
Wow. And the final one is, how many crew are on board?
So on James Cook we have a crew of 22, and then we can carry up to 32 scientists and technicians.
Okay, so we've had a few questions in from the docks. So the first one was, how long do vessels stay at sea normally? So trips aboard James Cook and other research vessels can vary in time. This one we're currently on is about 4 weeks, but it can go on deployments up to 8 weeks. I think the maximum is about 50 days for a deployment. How far from shore do you usually work in? So again, the research vessel can go anywhere and anywhere that it's needed. So it's gone to the Antarctic, it can go across the Atlantic and the Pacific. In our particular case, we've been staying reasonably close to the shore, so we've only been about 24 hours steam from Montevideo out here on the shelf waters around Uruguay. Do you have any divers on board? No. So this project, we don't have any need for divers on board. We'll be doing all of our measurements using equipment that we've either winched in down under the ocean surface, or we're using seismic equipment to measure ocean layers and stratification using sound, which we discussed earlier. How many scientists and crew are on board? John's already discussed that, so I'll cut that. What are the main technical issues you have to worry about? Engines, sewage, generators, etc. So that's more of a question for the engineering team. I can't really comment on that. They do a great job of keeping it working around the clock for us to do our science. From a science perspective, we've had quite a few troublesome technological deployments so far. So our passive acoustic monitoring system required a little bit of wriggling around at the beginning to get working, and also our dissolved oxygen sensors haven't always been playing ball. But overall, it's been a great challenge and experience to work together to solve these problems and get some great science and data out of it.
So I'm with Dan and Andrea in one of the laboratories in the ship, and this is where they do the oxygen measurements. So we've got a question from Owen and also Ruby and Jemima, and they ask, why do you measure oxygen levels in the ocean?
So by measuring oxygen levels in the ocean, we can work out how old the water is, so how long it's been since that water was last at the surface of the ocean. And we can also understand what life might be living in that part of water.
Yeah, and we get information about biology in general, all the plants and animals in the water that either produce oxygen or use oxygen.
And Owen also asked, how do we measure oxygen in the ocean?
So we use a computer that travels all the way from the surface of the ocean down to the seabed, and as it goes down it takes measurements of oxygen at different levels.
And then we take water samples and analyze them here in the lab to check that the sensor, the computer that we sent down, is working well.
And you can see here this bright yellow, the colour is an indication of how much oxygen is in the water that we sampled.